Welcome everybody. Alright, so we have an exam this week. Our exam is on Friday, and that's been on our revised schedule since it was updated on the 22nd of February. So I hope that's not a surprise to anybody that we would have another exam. It's going to follow the same format as our previous test, where it's available on Blackboard during a 2-hour window. And so that means you've got during our class time and then also 30 minutes on either side of our class time. So the exam PDF file will be available for viewing and download and printing on Blackboard from 10:30 until 12:30. Hold on, nope, that's wrong. Okay, it is from 11:30 until 1:30. Yeah, that's more like it. Thank you, Cameron. I think you noticed at the same time as me. Yeah, so 11:30 to 1:30 p.m. And just as before, you can use your textbook, you can use your notes, you can refer to your previously solved homework assignments and in-class exercises, but you're not allowed to collaborate with any other people, and you shouldn't refer to any websites during the test. So, obviously I don't want you to cheat, right? And so don't do anything that you know is wrong during the test. It's supposed to be your work. And then you can either solve your work on a blank piece of paper if you don't have a printer available. Of course, if you do have a printer available, you can print it out and do your work on that. But if not, any hand calculations you should solve on a blank piece of paper and then scan that and upload it to Blackboard along with the Excel file, because just as with our first exam, on the second exam you will also be using Excel there too. Okay, so that's this Friday. A week from today is when homework number 10 is due, and then the project due date is Wednesday the 21st of April. So before we move on to today's topic, are there any questions related to the announcements? Okay, so what we're going to do today is an analysis procedure that is used to answer the question, how long should you own equipment? And when you have an old piece of equipment, it may be time to replace it when its performance is compromised. And so if you own an old car and now it's in the shop a lot, and because of the breakdowns, maybe you're late for work, or maybe because it's breaking down a lot, the repair costs are high. Or it could be that the older equipment now has decreased safety or a reduced quality of operation, just for whatever the reason. Sometimes it's related to reliability and productivity that we want to replace equipment. Another possibility could simply be that the old equipment isn't able to meet new specifications. And so the picture there is of a steel furnace, and an old steel mill may not be able to produce the same specifications of steel of a new plant. So let's say that over time, it could be computer hardware, it could be machinery, but there's lots of examples of when physical equipment needs to be replaced because the requirements out there, it could be standards or just what the market is interested in purchasing. Things have moved on and the old equipment simply can't do the old task. So that's another example of why you may need to replace an item. And a third possibility could be maybe the item is still operating the same way as it always did, and maybe it's not necessarily that the requirements have changed, but sometimes equipment just becomes obsolete because other similar equipment is so much more sophisticated and advanced. So you could still type a paper, for example, on an old Apple IIe computer. And this is the kind of computer that they had when I was first learning how to use computers in elementary and middle school. And it didn't even have a color screen. That's how kind of rudimentary it was. Is the screen, the light was green and the background was black. And so you could type a paper on it and it could still work, but it didn't easily do things like spelling and grammar check. It didn't easily do things like adjusting fonts or spacing. It's just newer equipment makes this old stuff obsolete. So any one of those three possibilities could be why you're interested in replacing an item. So what we're going to learn about today is a procedure, a quantitative procedure that helps to identify how long you should own equipment. And in that process, we're going to be looking at the cost of ownership. How much it costs to own something isn't just the initial upfront expense of buying that item. It also includes the operating costs. And so total ownership has a couple of components. Now, first of all, this phrase capital recovery, what I mean there is that when you buy, let's say, a car, there's the initial purchase price of the car, which is a present value expense, and some years in the future, you're likely to sell the car, whether it's on the secondary market to another buyer who's going to continue driving it, or it could be that you're going to dispose of the equipment just as scrap. And so if it's to a scrap metal dealer, then they would maybe pay you based on how heavy the car is because they just want to extract steel from it. Whichever is the case, there's an upfront outflow, which is the amount you pay to acquire the equipment. And then in the future, there's a future value inflow, where you're selling the item and getting money back. So if you take that, think about it, try and visualize if you can, the cash flow diagram, outflow at zero, inflow some year in the future, you can turn that into an annual equivalent. And so whether it's using the payment function in Excel, or whether you're finding an annual series with the lookup factors, capital recovery is the amount that's an annualized equivalent of the initial purchase price minus the sales price in the future. The other component of ownership is the ongoing maintenance and operation costs. And so in the case of a vehicle, it may be the oil changes, new tires, it could be the fuel that you put into the vehicle. And so all of those factors have to be accounted for to know the total ownership cost. Now the reason I mention total ownership cost is because that's what we want to minimize. You may have noticed this figure in our textbook. At least I hope so, if you're following along and doing more than just listening to the lectures. If you're reading the textbook and really trying to learn and absorb the material, then you would have already come across this figure. And what it illustrates is that there's this kind of happy medium between balancing the operating costs and the acquisition costs. And so what we want to do is combine together those two different categories of costs. And look at this figure. On the horizontal axis, we have time. And so starting at 0, which is when you'd first buy the item, and then moving to the right just refers to the passage of time. And so consider, for example, the annual worth of the annual operating costs. And so as you own a piece of equipment for more and more time, the operating costs are going up. So think about why that might be. Why on an annual basis is it becoming more expensive to own and operate equipment when you have it for a really long time? Well, it could be just that it's breaking down more often. And so in this operation, Anthony's got it exactly right. In this operation, what you do is you add up the entire operating costs for the entire lifespan of a piece of equipment, and then you find the annual equivalent so that it's the same amount every year. In this procedure that we're going to do today, we're going to do a procedure with Excel. You find the annual operating costs for each individual year, and then you combine it all together and spread it out evenly over the entire lifespan so that it's an equal amount. And so here this abbreviation means the annual worth of the annual operating costs. So here AOC means annual operating costs. So over time, operating costs go up. And now think about what's happening to capital recovery. Capital recovery costs are getting lower and lower the more years you own an item. I just sold my car a week ago Friday, so like 9 days ago. And the car that I just sold, I owned it for 12 years. and I initially bought it for $7,500 and I sold it for $3,500. So I only lost $4,000 worth of value in 12 years. So I think that's pretty good. Like, I'm spreading out that difference between the acquisition and the disposal cost. So that $4,000 spread out over 12 years means I think that I was only spending $333 a year to own that car. Now, that's the capital recovery costs, and that's not taking the time value of money into account. But just roughly speaking, the point is when you spread ownership costs over a really long period, then your capital recovery is low simply because the denominator is large. You know, dollars per year is low if you're spreading out the ownership costs over a lot of years. So here, this blue line is we're adding the two curves together. So if you own an item for just a couple of years, so let's say if I buy a car and I own it for 1 year, I would have pretty high capital recovery costs, but relatively low operating costs. Have you ever heard the old saying that when you drive a car off of the lot, it immediately loses 20% of its value? I don't think that's necessarily true anymore. It seems like used cars hold their value a little bit better than they did in previous years. But the point is that there's a lot of depreciation early on. Depreciation is faster in the early part of an item's life than in the later years of an item's life. Plus, if you're only owning it for 1 year, all of those financing charges and the delivery fee that the dealer charges and the prep fee and documentation fee and sales tax, there's just a lot of expenses that aren't spread out over very many years. And so on the far left extreme of the graph, your total costs are high because capital recovery is high. But if you own an item for too long, then capital recovery is low, but your operating costs are high because it's always getting repaired. And that's kind of why I sold my car, as I could tell, it had some repairs that it needed, and I didn't want to make them. It was just too much of a nuisance. So the happy medium, the optimal operating point, is what's called economic service life. So this is a technical definition of the economic service life is the number of years that minimizes the total annual worth of costs. So how long should you own equipment? You should own a piece of equipment for the number of years that minimizes the total annual worth of costs. All right, so does anybody have questions about that idea? All right, now in a replacement study, you'll compare different alternatives. You'll compare the thing that you already own, which is the Defender, to a potential replacement, which is called a Challenger. And the market value is the value of a piece of equipment that you already own if you were going to sell it today. Economic service life, as we've just talked about, is how long you should own the item. And so it's the number of years that minimizes the total costs. And in the case of the Defender, the first cost is its current market value. But in the case of a Challenger, it's the actual purchase price of whatever equipment you're considering to buy. Now, remember when I was telling you I just sold my car? The fact that I recently put new tires on, and the fact that I recently changed the master cylinder on the clutch, and the fact that I had a relatively new battery in it, none of those things matter. Those are all sunk costs. Those are previous expenditures that don't have a direct relationship on the current value of the item. Because when you sell a car, people take it for granted that it has tires, that it has a battery, that the clutch works. And so those things are just factored in as a minimum for the equipment. And so one of the mistakes that people often make is artificially including sunk costs, which are previous expenditures, into deciding how long to own and keep equipment. Okay, so we're going to talk about economic service life today, and I'm going to teach you the procedure with this example. And I'm not providing a template file because I want you to go through the process of setting all of this up from scratch from the very beginning, because I think that the process will make more sense if you're not just plugging numbers into a template I've given you. And this is one of the more complicated parts of the semester. Remember, I said that the tricky stuff this semester is external rate of return. That's kind of tricky. Incremental analysis is kind of tricky. This is another one, economic service life. It's one of the peaks of the course that if you can figure this out, then you're on track. Then you'll do just fine on the exam. All right. So we've got a piece of equipment that can be purchased for $20,000, and if you sell it after 1 year, then you could get back $10,000. If you sell it after 2 years, then the market value, MV, the market value is $8,000. If you sell it after 3 years, and so on and so forth. So this column of MV is simply when you sell the item, how much money you could get in return on the market. We're going to use a 10% interest rate, and then the economic service life is going to take into account the market value in order to calculate the capital recovery costs for each year of ownership. And then we're also going to factor in the operating costs. And you may remember from this figure, this said the annual worth of annual operating costs. Okay, now look at this column of operating costs. It's going up gradually. So we're going to have to jump through kind of an unusual hoop, because we want to, for example, if we own it for 3 years, then we don't want each year to have different operating costs. We want to find out what would be the equivalent amount so that we would pay the same amount of operating costs each year of the 3 years of ownership. So we have to turn 5,000, 6,500, 8,000. We have to change a varying operating costs and find out the fixed annual equivalent. So the process I'm going to show you with the spreadsheet will do that, but I just wanted to put it out there that maybe the most complicated thing that people struggle with is finding the annual worth of the operating costs. All right, so this is what the in-class exercise, we're going to kind of format it looking a little bit like this. We'll get there. I'll go through it with you. And I think maybe if we take a look at the handout from today, so here's the value that the in-class exercise paper that you can print out in advance. I'm going to tell you the columns that we should have in the spreadsheet. All right, so let's do this together. Let's start up Excel. This may be one of those class meetings where if you have a second screen, it's a little easier for you to both work and watch at the same time. I noticed that some people seem to join the class meeting on their phones, which is a fine option. Maybe the screen is a little bit small if you do it that way, but that's all right. All right, so we're going to do economic service life analysis. So let me just type that at the top, and remember, it's a good idea to save your work. Because you'll have a homework assignment related to this, and I'd be sorry for you to have, to feel confused. Like when you see an economic service life analysis problem on the homework, it's always a pity when somebody doesn't recognize what the steps are, because we almost always have in-class exercises that are pretty closely related to the homework. All right, so the interest rate is 10%, and our first cost for this equipment is $20,000. All right, so let's put both of those things in. First of all, the interest rate is 10%, which we write as 0.01. Let me make that even a little bit bigger. All right, and first cost, the purchase price of the item is $20,000, and so I'm going to put that in as negative $20,000 because it's an outflow. And we are going to have some inflows in this because the market values will be money coming back to you if you sell the item. All right, now the column suggestions I'm going to be following are on that handout that you've got. So the first column we're going to have is year. Okay, so we're going to have year in column A. Column B is going to be called the market value if sold in a certain year. Now see how that's really wide? I don't necessarily want that column to be so wide. So let me show you a little formatting trick that you can use. When you're in that cell, across the top ribbon here, there's wrap text. So do you see on the Home tab and then wrap text? If we click on wrap text, what it will do is it will make it so that it all fits into a single column like that. So the column doesn't have to be quite so wide. In fact, let me do that for all of these through G. I'm going to wrap text for all of them. And so then that way what we can have is a little bit more description without making the spreadsheet abnormally wide. Okay, so this next one, operating cost for a certain year. Okay, and we'll just make it a little bit wider. Maybe 2 rows of text would be good. Okay, so then D is going to say the PV of cumulative operating costs to date. Okay. Column E, the annual worth of the present value of the cumulative operating costs to date. That's a mouthful, right? Okay. And column F, capital recovery. Column G, total annual worth of cost. Oops, PW of costs. All right. So we've just put these column titles on, and now let's translate the data that's given in the table, put it on screen. So we know the market value and the operating costs for a certain year. So in year 1 through 5, we know the market value for each year. So it's 10,000, 8,000, 6,000, 2,000, and then this piece of equipment has no salvage value whatsoever if we sell it in year 5. So it goes down to 0. And then translating the operating cost data. Okay, so here's the operating cost data that I'm going to put into the spreadsheet. So if we own it for 1 year, then during that year there's $5,000 of operating costs, $6,500 if owned for 2 years, $8,000 if owned for 3, $9,500, 4, and $12,500 if owned for 5 years. Okay. Now, column D, PV of cumulative operating costs to date. Now, I've got some hints here that I'm going to paste into the, I'll put the hints into the spreadsheet. I'll type them here. So, for example, this column A was just given data, given years. By the way, A that I'm referring to up across the top here, each column has a letter label. So A is just the given years. B was the given market value data. Column C was the given operating cost data. Column D, we're going to use the NPV function of the range so far. Okay, now this is really important. I'm going to bold this range so far comment to draw attention to what I mean. So if we only own it for 1 year, what we want to do is we want to take these operating costs to times 0. The PV function will take it to times 0. So this $5,000 operating cost would be due at the end of the first year. So what effectively we want to do is we want to take 5,000 at year 1 back to time 0 using 10% discounting. Okay? So it's going to be 10% less at time 0 than it was at time 1. So the function that we're going to use is NPV of the range so far. So equals NPV. Okay, now it's asking what is the rate. So I'll click here on the interest rate. And now remember, the NPV function, you should only put in values that are in the future. You should never put something that's already at the present into the NPV function. By the way, I guess I ought to anchor that, right? I want to anchor that reference up to the interest rate. Okay, so it's just year 1. So if we're on the first row, we're just moving the amount that's in year 1 back to time 0. And let me change the formatting of that because you already know I just don't like the looks of. I'll change all of this all at once just to be the currency formatting. I think it looks a little better. Okay. So what it's saying is if you take 5,000 and discount it, then it's going to be worth in present terms $4,545. You may be wondering, well, why not $4,500? That's not the way it works. When we go forward in time, we would multiply by 1.1. But if we're going backward through time, then we would use the, we don't simply multiply by 0.9. I think we did a similar calculation to this in the first or the second day's in-class exercise. Okay, so what that's saying is if you move 5,000 at time 1 back to time 0 at 10% discount rate, then it's $4,545. Okay, now let's do that for all the rest of these as well. So for instance, if we are in year 2, what we want to do is if we own it for 2 years, we have to pay the 5,000 operating costs and the 6,500 operating costs. So we want to take both of those back to time 0. So the NPV, the interest rate is this one. I'm going to anchor that reference. And now the years that go in there are the years that we've owned the equipment. Okay, so it's saying now if we own it for 2 years, we have to take back 5,000, which was at year 1 to time 0. And also take the 6,500, which is in year 2, back to year 0. Okay? So if we take both of those back to time 0, then it's 99.1736. Now, if I drag this formula down right now, it would have a problem. Look, it's taking these first 2. But if I drag it down, I want it to always be looking at the top one. But I would want to continue making like the way a range is defined. You see how it says here C7 colon C8? This is the range, C7 through C8. So like the next one, I want it to be equals NPV, interest rate. Okay, now the range is going to be the first 3. So now it's saying C7 through C9. So if I want to be able to drag that down, I need to anchor the first cell. So I've just pressed the F4 button for the first cell so I get the dollar signs in front of C7. And now by doing that, what I can do is I can drag it down and it will always include the first cell. So like for example with this last one, it's always looking at the top one, but then the bottom one keeps moving down further depending on how far I've dragged the cell, like which row I'm on. So any questions? Are we all on the same page up to this point? Does everybody have these same values? Just go ahead and interrupt if you've got a question. I would be glad to hear it. Okay, so that was column D. We were using the NPV function. In column E, use the PMT function on column D. Okay, so we found the lump sum present value. So if you take all of this ownership, so for example, if you knew that you were going to have to pay $5,000, then $6,500, then $8,000, then $9,500, then $12,500, all of that in the years that it occurs is equivalent to a lump sum amount at times 0 of 30,178. So for each row, we want to find out if we were then going to spread it back out over how many years the item is being owned, what's the equal annual worth amount. So we're going to use the payment function, so equals PMT, and the rate is 10%, anchor the reference there, N is whichever row we're on, so year 1 for example, and then we're going to put in the minus of this because this is a present value. So we want to do the minus sign because of the change in sign that Excel always does. And then this amount is in the present, and the PMT function will find an annual equivalent. That's what PMT does. It takes either a present or a future and it annualizes it. Close parentheses. All right. So it's no surprise that that first one is 5,000. We kind of already knew that. If you take 5,000 to times 0, and then from 0 back to time 1, then it's 5,000. So that first row isn't very informative. But the next one, what it's doing is it's saying if you have 5,000 in the first year and then 6,500 in the second year, you could either pay those amounts in the year that they occur, but it's a little bit, it's not great if your costs are always changing. It's better, it's more convenient for companies if they face the same cost every time. And so this is kind of smoothing things out a little bit. Instead of paying a different amount each year, this is how much you would have to pay during year 1 and during year 2 so that your operating costs are an equal amount each year. So that's what column E is you're annualizing the present worth of the cumulative operating costs to date so that you can have the same annual worth every year. So if you owned it for 2 years, then this is how much your operating costs would be each year. So now I can drag this down to the next row. So if you own it for 3 years, the annual operating costs are $6,404 per year. Because it was 5,000, then it was 6,500, then it was 8,000. So the operating costs are going up. Therefore, the operating costs on an annual worth basis are also going to be going up. So let's drag that down through all of them. So now we know what's the cost going to be for each of the years. Capital recovery has both the first cost and the market value. So it takes both of those things into account. So column F is going to be use the PMT function on first cost and market value for this year. Now let me show you what I mean by that. So if we own it for 1 year, we pay 20,000 at times 0, and then when we sell it, we get 10,000 back. So then how much is your capital recovery cost if you only keep it for 1 year? So we can do the payment function equals PMT, and it's asking for the rate, so we'll click here up on the interest rate area and press F4 so that it anchors that reference. Now NPER, number of periods, it's only 1 year, so that's pretty straightforward. The interesting thing is we can put in both the present value and the future value into the same function. Normally we'd only do one or the other. You see the PV and then the next field is FV, but we can have both a PV and an FV, and it will find out the payment that balances those two things. I think we still need to put the minus sign in like we generally do. So let's do this. Let's say minus of, here's our first cost as the present value. I'm going to anchor that reference because the first cost always stays the same. The first cost doesn't change when we move from row to row. If you own the item for 3 years versus 4 years, you still have the same purchase price at time 0. So that's why I anchored it. Now, comma, here in the FV field, we'll put minus of this disposal price. So you can see in the formula, we've got the rate, the number of years, the initial purchase price, and the market value price when it is being sold. Now I think we need those minus signs. We'll just have to see if we get an unexpected result here. Minus 12,000. Yeah, that's correct. So what it means is if you only own it for a single year, then your cost of ownership during that year for capital recovery is $12,000 because of the time value of money. It's not just the $10,000 difference between the purchase price and the sales price. It's $12,000 because the money at time 0 is more valuable than the money that is being collected when the item is sold. So we can drag this formula down like that, and it will calculate the capital recovery depending on how many years you own it. So if you own it for 5 years, then you're spreading out that first cost over a greater number of years. And even though you don't get any market value, your operating costs are still, your capital recovery costs are still lower because, it's 5 years of ownership. So that was column F. And the final column G, let me type this here, G, it's E plus F. So we're just going to add together the annual worth of the present value of cumulative operating costs to date and the capital recovery. So equals the amount in column E and the amount in column F. All right, so if you own it for a single year, then your total costs are $17,000. And most of that is in the capital recovery. Your operating costs are relatively low. But if you own it for 2 years, it's cheaper because the capital recovery costs came down a lot and the operating costs didn't go up that much. So if we think about graphically where we're at, we were at the far left edge when we only owned it for 1 year, and then we were able to bring the total costs down a little bit for 2 years of ownership. So here 2 years of ownership is less. 3 years of ownership, even cheaper than 2. See how the trend continues. Okay, now prices look like they're going up again. The total cost of ownership is increasing because the operating costs are going up. So look for the minimum amount. This is the lowest cost. So that's the economic service life. This equipment should be owned for 3 years. In other words, 3 years is the economic service life. So the economic service life means the ideal number of years that minimizes the costs. So that's economic service life analysis. It's kind of an abstract notion. I think the thing that probably the two mental leaps that you have to make is thinking about what does this mean? Like it's kind of like, let me just throw together a sketch really quick here on the screen. This will be ugly, but I hope it maybe will illustrate a point. Think about what our operating cost cash flow diagram looked like. So here's time, okay, and I'm just going to draw a bunch of arrows for the amounts. So there was 5,000, and then there was 6,500, and then there was 8,000, 9,500. And then it went up to 12,500. So this is kind of like what the cash flow diagram would look like for the operating costs. What we do in column D is we take all of this to times 0. So it would look in column D, what we're doing is for whatever row we're on, is we're taking that many years of operating costs and just finding the single lump sum annual equivalent. So we're taking it all to times 0. All right. So that's these operating costs, that's column C. Column D is you're just taking it all to the present as a lump sum. And then in column E, what you're doing is you're trying to find out what would be an equal annual amount. So if we were going to just make it so that it's the same amount every year, I said this was going to be ugly, and I didn't lie. Okay. So now if I created a bunch of copies of these, we're going to find out the equal amount every year, and so on. I think you get the idea. See how it's the same height? So we take a cash flow diagram that has different heights, and we're going to find out what would it be if it was the same amount every year. So if you're going to own it for 4 years, then in reality you have operating costs of 5,000, 65, 8,000, 9,500. We want to find out how much would you have to pay so that it's the same amount every year. And so that's what this amount in column E is. So that's one of the intellectual leaps that you have to make to be able to do economic service life analysis. And then the other is understanding capital recovery. And capital recovery is simply where you have the first cost, which is an inflow, you're spending money, so it's an outflow. And then the market value when you sell the item is an inflow, and you're finding out the annualized difference between the two. So I'd encourage you, if you could use some more practice on this, then sooner rather than later is my recommendation. While this is still somewhat fresh in your mind, practice it again. Practice the in-class exercise again, or get an immediate start on the homework before you have a chance to forget what the process is. So speaking of the homework, it's not posted yet, but as soon as we finish our class, I'm going to load that on. Homework 10, I'll load it onto Blackboard so it'll be available to you. Remember that the big thing at the end of the week is on Friday we're going to have our second midterm exam. So that's it for today, everybody. Hope you have a good one. I'll see you in class on Wednesday. Thank you.